Hi, welcome Transitional Math students. Mrs. Robinson here to work practice benchmark chapter 3 with you. So come here if you have any questions on these problems and you can get help. Let's start with the first one. Bay has 21 yards of embroidery floss to make bracelets. If each bracelet requires 2 1/3 yards, how many bracelets can she make? So we have 21 yards and that's how much we have total. And one bracelet takes 2 1/3 yards. So I need to figure out how many bracelets I can make with 21 yards. I'm just going to take 21 yards and divide it by 2 1/3 yards. And that will let me know how many bracelets I can make with that material. The yards are going to cancel out, the units will cancel out, and I'll have 21. And I'm going to write this across like this, divided by, because this divide sign, I'm going to write it like this, divided by 2 1/3. That way I can change this to a mixed number. I'm going to change it back to a mixed number by taking the bottom, 1/3, and multiplying it by 2 to get 6, and then adding 1, which would be 7. So this will be 7/3. So I'm going to have 21 divided by 7/3. Now division can be turned into multiplication when I call it keep, flip, change. Keep the first one, flip the second one, change that to multiply. So I'm going to keep the first one, and I can make that be a fraction by just putting it over 1. Any whole number can be turned into a fraction by putting it over 1. So 21 over 1, I keep the first fraction, I flip the second one to 3 over 7, and I change this to a multiply. Now I have a multiplication of fractions. I can multiply straight across the top and reduce at the end, or the better thing to do is to cross cancel before you do your multiplication across the top. And I'm going to go 7 goes into 21 3 times. 7 goes into 7 1 time. These don't cancel, these don't cancel, these don't cancel. So I'm pretty much reduced as much as I can. Now I'm going to multiply straight across the top. So 3 times 3 is 9. And straight across the bottom, that's a 9. Doesn't look much like a 9. And then straight across the bottom, 1 times 1 is 1. 9 over 1 is just 9, so I can make 9 bracelets. I apologize for this horrible writing, but that's what I get on this tablet. All right, let's go to number 2. All right, number 2 asks us to sum these two fractions. I have a whole number and part of a number. I have another whole number and part of a whole number. So when I'm adding fractions, I have to have a common denominator. These two have common denominators, so I can write them out like this. 7 2/3 plus 5 1/3. I can go ahead and add my whole numbers over here and add my fractions over here and put them together at the end. So 7 and 5 is going to give me 12. 2/3 and 1/3. Well, 2, since I have common denominators, 2/3 plus 1/3, I can just add straight across the top, will be 3/3. So when I add these together, I get 3/3. So I have 12 and 3/3, but I know 3/3 is equal to a whole number 1. So really what I have is 12 and 1 more. So together, I'm going to have 13. All right, and you can think of this like adding. This is 12 plus 1 more. Okay, let's go ahead and go on to number 3. Which fraction is equivalent to 3 2/3? Well, these all look like mixed numbers to me. So I'm going to go ahead and change this to a mixed number. I take my bottom number, I multiply it by the whole number, and I add the top number. So 3 times 3 is 9, plus 2 is 11 over 3. So it would be D. And on to the next one. Okay, number 4 asks us, what is the multiplicative inverse of -7 over 9? Now this word looks so fancy, but all it means is reciprocal. And reciprocal is another fancy word just to say flip it. If it's negative, it stays negative. So the reciprocal of -7 over 9 would be -9 over 7. And the whole point of the reciprocal is when I multiply it straight across, I get 1. Negative 7 times negative 9 would be positive 63. And 9 times 7 would be positive 63, so that would give me 1. All right, so it's going to be B, negative 9 over 7, or negative 9/7. Okay, number 5. In a survey, 0.64, if I move the decimal over 2 places to a percent, that's 64%. 0.64 students stated they exchange text messages every day. What is the value written as a fraction? All right, if I want to write this as a fraction, I can know this is the tenths place, this is the hundredths place. So I'm going to write this as 64 out of 100. Luckily, it wasn't a repeating decimal where I had to do that weird let x equal each number and then multiply both sides by 10 and subtract. That's kind of a tricky little game you do, but this is just straight up. Tens place, there's 1 0. So how many decimal places do I move over? I move over 2 decimal places, so I need to make sure I have 2 zeros here. That's how I remember. Now let's reduce this fraction. This isn't one of my answers. I need to reduce this fraction. They're both even. Great. I can divide them both by 2. Is there a bigger number? Well, I know 64 is divisible by 4. Let's divide that by 4 and 100 by 4. Well, 64 divided by 4 is 16. 100 divided by 4 is 25. So they are both divisible by 4. 16 out of 25, that's the lowest I can go. They don't have anything else in common that I could divide out. So I'm going to go with A, and you're done. All right, which symbol can be substituted for here to make this statement true? So are these equal? Is one greater? Is one less than? Plus? We're not plussing anything here, so that one doesn't even make sense. I need to get a common denominator to see which of these fractions is bigger, or I can use my handy-dandy calculator and turn it into a decimal. Let's work common denominators. 9 and 8 do not have any common factors, so their common denominator is just going to be 9 times 8. So if I have a common denominator of 72 for both fractions, in order to make 9 have a denominator of 72, I need to multiply top and bottom by 8. When I multiply top and bottom by 8, it's like multiplying by 1. It doesn't change the value. So 8 times 9 is 72, and 8 times 5 is 40. Now, careful, it was negative. This is negative 40. Now, to make this have a denominator of 72, I need to multiply top and bottom by 9. 8 times 9 is 72. And then 9 times 3 is 27, and it also is negative. So now that I've changed them both to a denominator of 72, I have negative 40 over 72 and negative 27 over 72. This one looks bigger, however, they're negative. So remember, bigger is actually smaller. And you're looking at a number line. If this is 0, negative 1, negative 2, negative 3, negative 3 is actually smaller than negative 1. It's a lesser value. So this would be less than this. So this would be greater, and that's the symbol I should be using here, C. Now if I just wanted to take my calculator and go 5 divided by 9, and I'm going to get negative 0.55 repeating, so I can just put the repeating sign over here since I wrote it twice. I'm going to put it over here. And then divide these out. 3 divided by 8. It's going to be 0.375 negative. And you can see 0.5 will be greater than 0.3, however, they're in the negative direction. So this one will actually be greater. So if you did the division either way, when you have those negatives, it's tricky. Remember, the bigger number is actually less than in the negative direction instead of greater than like we have in the positive direction. So still C. All right, on to number 7. All right, we're going to multiply this expression. 4 times R times S. And they give us R is negative 1/3, so this will be 4 times negative 1/3, not a subtract, it's a multiply even though that's negative. And then the S is 7 over 8. Now multiplication is commutative, it's associative. I can multiply straight across the top, I can flip these around in different orders, it doesn't matter. I think it's easier if you write this as a fraction too, so let's write this as 4 over 1. And then that's multiplied by negative 1 over 3, and I'm just going to attach the negative to the top. I could attach it to the bottom, it doesn't really matter as long as I attach it to one or the other, not both of course. All right, so now that these are all multiplied together, I can actually cross cancel them all together. So 4 actually divides into 8 and leaves me with 2. 4 divides into 4 and leaves me with 1. 3 and 7 don't cancel. Nothing else cancels. So I'm going to multiply straight across the top. And I'm going to go 1 times -1, that's -1. And then -1 times 7 would be -7. Then 1 times 3, that's just 3. And then 3 times 2 gives me 6. So -7/6. Now you'll notice that's not one of my solutions. So I need to go ahead and change it to a mixed number. 6 divides into 7 one time with 1 left over. So 1 out of 6 left over. And I have it negative. So it's going to be -1 over, or excuse me, -1 and 1/6. So it will be A. All right, on to the next one. All right, number 8, of the 475 boys attending Boys State, 18 out of the 25 play a musical instrument. How many boys attending Boys State play an instrument? There's a couple ways to do this, but an easy way just would be to take 475 boys and multiply it by this fraction, 18 out of 25. And 18 out of 25, if you actually divide this fraction, you're going to get a decimal. It's 0.72. If you change that 2 decimal places over to a percent, it's 72%. So really I'm multiplying this by 0.72 to figure out 72% of these boys. So what I'm going to do is put this over 1. I can cross cancel here if it works. Does 25 divide into 475? And if it does, reduce how many times? Well, 25 goes into 475 19 times. And then 25 goes into 25 1 time. And then I'm just going to multiply across the top and across the bottom. So let's go 19 times 18, and that's going to give me 342. And then 1 times 1 is 1, so it's just 342. So I did 475 and I multiplied it by this fraction. 18 out of the 25 students play an instrument. So if there's 475 students, how many is that? Well, let's see if it even makes sense. 342 out of the total 475 students play an instrument. Is that about 18 out of 25? Well, do it. See if 342 divided by 475 gives you that same percentage, and it does. It's 0.72 or 72%. So that would be the correct answer. So 342 boys. Now when you get to cross multiplication, you could set up a ratio. If I have 18 out of 25 boys playing instruments, I could set this up as a ratio of how many boys out of 475 playing an instrument. And then you could do this cross multiplication deal, which would give you the same answer. You go 475 times 18 and then divide that by 25. So if I did that, it would look like this. 25 times x would equal 475 times 18. And that would be a very large number, 8550. And then I divide both sides by 25. And you get x equals, and if I take that on a calculator and divide it by 25, I'm going to get 342, which is that same ratio right there. So this would be setting up proportions. How many out of 475 play an instrument if 18 out of 25 do? And you would set up a ratio and proportion. All right. That's just another method to do it. Let's go ahead and look at number 9. What is the product of -2/5 and -11/12 in simplest form? So it's just a multiplication problem. We're going to go -2 over 5. You can attach the negative to the top or the bottom, one or the other, not both. I'm going to attach the negative up here, -11 over 12. Now remember multiplication, I multiply across the top and across the bottom, and I can cross cancel too. I know that 2 divides into 12 and leaves me with 6. 2 divides into itself and leaves me with 1. The negative is still there, it didn't divide out. 5 doesn't go into 11 and 6 doesn't go into 11. There's no more canceling I can do, so I'm now going to multiply across the top. -1 times -11 gives me +11. 5 times 6 gives me 30. And I'm going to have 11 over 30, and it's C. On to the next one. All right, Philip plotted a point and its opposite on a number line. Which 2 points could Philip have plotted? Now a point and its opposite on a number line just means the point opposite 0. So on the other side of 0 is what I should say. So for example, if I had 2, Its opposite would be -2. It's on the other side of 0. So all I'm looking for is the number and the negative of the number, or the opposite of the number. So if I want to reduce all these in C, I can already tell you it's going to be A, but if you look at B, 6/8 and 1/8, this isn't 1/8 and -1/8, so it's not B. 5/8 and 8/5, these are not the number and its opposite, so this is not -5/8 and 5/8, no. 7/21 and 3/1, once again, I'm looking for 3 and -3. Nope. So here, if I reduce this fraction, 2/8, well, 2 divides into 2 one time, and 2 divides into 8 4 times. 2/8 reduces to 1/4. So I have 1/4 and -1/4. So it is going to be A. That's all I was looking for. Super simple. Number 11, which decimal is equivalent to -3/8? You can divide that on a calculator super quick. If I divide 3 by 8, I'm going to get 0.375. And it is negative, so it's negative, and you can do a leading zero if you want, 0.375. It is not repeating, so the bar doesn't belong there. It's just negative 0.0375. If you were going to do this out by hand, you would take 8 and divide it into 3. Now, I can't divide 8 into 3, so I'm going to add a decimal and several zeros. I don't know how many I'm going to need. I'm just going to add as many as I do need. It is negative. We'll take that into account at the end. Let's just go ahead and do the division here. 8 does not divide into 3 anytime, so 0 times 8 is 0. I'm just going to do this long division way. Bring down the 3, bring down the next 0. 8 goes into 30. Well, it goes into 30, let's see, 3 times. 3 times 8 is 24. That's a 4. Sorry. Okay, subtract and bring down. 30 minus 24 is 6. Bring down the next 0. 8 goes into 60. Let's see. 7 times, because 7 times 8 is 56. Subtract and bring down. 60 minus 56 is 4. Bring down the 0. Sorry, 8 goes into 45 times. And that is a 5. 5 times 8 is 40, so it terminates. It ends in 0. It does end. It doesn't go on forever. And then I go ahead and bring straight up my decimal. So my solution is 0.375, and it was negative. So my solution would be negative 0.375. Same one I got when I used the calculator. Just be careful you don't fall for that repeating line there and get that one wrong. All right, number 12 says, a toll-free customer information line answered 105 of 120 questions in one day. What's the daily success rate of this information line? So success rate, I'm guessing, would be the questions answered out of the total number of questions. Let's go ahead and write that. It's going to be 105 divided by 120. Now, I can go ahead and divide 120 into 105. It's not going to go any times. I'm going to have to add a decimal and some zeros. Those are big numbers, 120 to 105. My choice would be a trusty little calculator, or on your phone, or however you have it. Just do 105 and divide it by 120. And you are going to get 0.875. It does terminate. It does not repeat. So it's going to be C. And there you have it. Okay, so number 13, what's the quotient of 2a over b divided by 4a over b? We have two fractions with some division. So whenever I'm dividing fractions, I remember KFC, some fingered chicken, KFC. I'm going to keep the first fraction. I'm going to flip the second fraction. That's the reciprocal when I flip it, or the multiplicative inverse. And I'm going to change the division to a multiplication. So keep, flip, change. Now, when I multiply, I can cross cancel. That makes this awfully easy. The b's are going to cancel. B divides into b. B divides into itself and leaves with 1. B divides in itself and leaves with 1. And then I can cross cancel over here. 2 divides into 4 2 times. 2 divides into itself once. A divides into itself once, and A divides into itself once. So I can divide those out. Now I multiply straight across the top. 1 times 1 times 1 is 1. Straight across the bottom, 1 times 2 is 2. 2 times 1 is still 2. So I'm going to get 1/2. And that would be A. Keep, flip, change, and then just cross cancel everything that cancels. All right. Identify all the sets to which the number 3 belongs to. Let's just review those sets real quick. The most basic number set would be natural numbers. Those are numbers you can count. 1, 2, 3, 4. That's your most basic set. Then from there you go to the whole numbers. Those are the same counting numbers. They go on, right, forever. Those are the same counting numbers, but with 0. 1, 2, 3, 4, and so on. Okay. Then you got your integers. Integers are all of these numbers, but the integers gets to be the negatives. So you can go in the negative direction forever. -4, -3, -2, -1, 0, and the positives 1, 2, 3, 4, on forever in both directions. The integers get to. After you get from integers, you get to the rational numbers. All of these are rational numbers because they can be written as a fraction. Anything that can be written as a fraction, A over B. So all of these can. 2 can be written as a fraction, 2 over 1. 0 can even be written as a fraction, 0 over 1. You can take any whole number or integer and write it over 1, okay? That's supposed to be a 4 over 1. So anything that can be written as a fraction is rational. What is not rational, or we call irrational, are things like pi, because it's a decimal that never ever repeats. It doesn't ever terminate, it goes on forever. If you have a decimal that repeats, it can be written as a fraction, and we did that in this lesson. If you have a decimal that terminates, it can be written as a fraction. We also did that in this lesson, or in this chapter. So irrationals are those decimals that go on forever. You can think of them, oh my gosh, they're irrational, they're going on forever, they're never terminating, they're never repeating, they're just crazy. So those are your irrationals. Okay, everything else that can be written as a fraction is rational. So one encompasses the next. If it's a natural number, they go like this. If I have a natural number, it's also a whole number and an integer and a rational number. And 3 is that. 3 is a natural number. So then it's going to be a whole number, it's going to be an integer, and it's going to be a rational number. So if it's in the smallest of the sections, it's going to be encompassed by all of these. If it's just an integer, then it can also be a rational number. So if it's a natural number, which 3 is, you're going to have, all right, it's going to be a whole number, it's an integer, it's a rational number, it's not even, it's an integer and a rational number, it's a rational number. This would most describe them. And it doesn't even say the natural number, which is fine, but it does say the whole number, the integer, and the rational number. It's not just a rational number. It's not just an integer and a rational number. It is not even. It is a whole number, integer, and rational number. So the best selection for this choice would be A, and even a more accurate would be calling it a natural number too. All right. And on to the next one, 15. All right, number 15. This is a review problem. How many centimeters are equal to 0.65 meter or meters? The easiest way to do this is to know this. Kilo, hecto, deca, then whatever the unit is, then deci, centi, milli. You just move the decimal place or multiply by 10 and divide by 10 depending on which direction you're going. So we have centimeters, sorry, we're in meters and we want to know centimeters. So meters would be the unit. If we'd like to go from meters to centimeters, here's my centimeters, I'm going to move over 2 decimal places. So I'm going to take my decimal and move it over 2 decimal places. To get from meters to centimeters, I'm going to be 65 centimeters. And that would be C. That's the beauty of working in the metric system, is everything's by tens. And you should think, if I go from meters to centimeters, I should have more centimeters than meters, because centimeters are littler increments. And that's how you can remember if you went in the right direction. All right, number 16. What is the value of x minus y if x is negative 1/5 and y is 7 over 15. So let's go ahead and do this. We want x minus y. So I'm going to plug in negative 1/5 for x, and I'm going to plug in 7 over 15 for y, but I'm minusing it. So minus what I want for y, which is 7 over 15. So I'm subtracting these fractions. They don't have a common denominator, so I'm going to get them a common denominator. 5 does go into 15 evenly, so 15 will be the common denominator. So if I want that to be the common denominator, this fraction right here already has that, so I'm not going to change this at all. It's just going to be negative 7 over 15. Now to get this to have this common denominator of 15, I need to multiply the top and the bottom by 3. Multiplying top and bottom by 3 is the same as multiplying by 1, and I haven't changed my value, so I'm good. 3 times 5 gives me 15. 3 times negative 1 would be negative 3. Now I've got common denominators. I can add or subtract. They are both negative, so you're going to add them together. Negative 3 minus 7 will be, they're the same sign, so you're going to add them and attach the sign. Negative 10 over 15. Now that does reduce. 5 goes into 10 2 times, and that is a negative, and 5 goes into 15 3 times, so my solution would be negative 2 over 3, and you're finished. All right, guys, that's it. If you need help on this practice benchmark, come work these problems and have a great day.